Hi, welcome back. One more thing that we can use the gradient for is for us to find equations of tangent planes to level surfaces. So what do we mean by that? So remember, when we're talking about level curves versus level surfaces, level curves are in 2 dimensions, level surfaces are in 3 dimensions. A level curve is what happens when you're setting a function value to be equal to a constant, and you'd like to see a whole bunch of points where that happens. A level surface is when you're dealing with a function of 3 variables, and it corresponds to, again, a whole bunch of points that all have the same value for that function. And we talked about that earlier in terms of like the temperature in a room, where we're talking about everything that's on the surface has the same temperature. And if you were to walk in this direction, you'd get the same temperature. And the thing we talked about last video was that if you walk perpendicular to that for in 2D, if we walked perpendicular to the level curve, the function would increase the fastest. Similarly here, if we walk perpendicular to this level surface, that is going to be the way in which the function increases the fastest. So we can use this to do some geometry. We can say, okay, a level curve is the gradient vector is the direction of the fastest increase. And so the gradient is perpendicular to this level curve at x naught, y naught. But not only is it perpendicular to the level curve, it's perpendicular to the tangent line to the level curve. So that's a useful thing. Similarly, if we have a level surface, this vector is not just perpendicular to the surface, it's perpendicular to the tangent plane to the level surface. So up until this point, we didn't have a formula for the tangent plane to a level surface, but we can use this because now we have the normal vector. The normal vector to this tangent plane to the level surface is the gradient vector. So we can use that to come up with a formula. All right, so this means that if we're going to write down the equation of the tangent plane to the level surface passing through x naught, y naught, z naught, we can do that. The normal vector is the gradient vector, which is f sub x of x naught, y naught, z naught, f sub y of x naught, y naught, z naught, f sub z of x naught, y naught, z naught. Those are our partial derivatives. And then we dot that with the point. This is the point slope version, normal version of the equation of a plane, where we go through the point x naught minus y naught, so x naught, y naught, z naught. So this vector dotted with x minus x naught plus, it's not a vector, this number dotted with x naught, let's say that again, this number times x minus x naught plus this number times y minus y naught plus this number times z minus z naught is equal to 0. Okay, and so one last thing we can say, let's say we are dealing with any curve that's lying on the level surface. We have any curve that's going on this level surface. I shouldn't have drawn a plane there. Let's try again. So we've got this level surface. Remember, this is some surface where everything on here has the same function value. Well, if we were to walk along it along some curve, then we know that it's going to we know that because we are on the level surface, then the function value of this curve if we apply it? Well, it's constant. And the reason why that's good is because when we take the derivative with respect to t of both sides and use the chain rule, then we get that this partial derivative of f with respect to x times dx dt plus partial derivative with respect to y of times dy dt plus partial derivative with respect to f with respect to z of dz dt is equal to 0. Well, what is this? This is another dot product. The gradient of f dotted with this the partials of x with respect to x with respect to t, right? That's r primed of t is equal to 0. And so we get an interesting information about how the gradient vector of this bigger function is related to the tangent vector to the curve at that point, at any point. All right, let's stop there. Talk to you later.